Hi, welcome to a complete course in calculus. This is Tejasa. In this video, we'll talk about what is called chain rule. So first, let's see what is chain rule, what is the special case of a chain rule, and then we'll see some examples, especially functions involving exponential function and logarithmic function. So let's start. What is a chain rule? Chain rule says if you have a chain of functions, which is, let's say you have h of x equal to f composed g composed k composed r, any composition, any number of composition. So this is nothing but f evaluated at g of k of r of x. That's what it means. So I'm closing it here. This here, for this one, this, that's what it means. So for two functions, for example, if I have h of x equal to f so if I have f let me erase that. So if I have h of x is simply the composition of two functions. But by the way, what is this composition means? This is the definition, f little o g. Little o, or we call it composition, is an operation like addition, subtraction, right? So this means definition, okay? So the definition of a composition is evaluating what we call it an outer function with respect to the inner function. That's what composition or chain means. Now, in this case, we want to, how do we find the derivative of a composition or a chain? So in short, how do we find the composition of f and g, which is nothing but h of x? So chain rule says, if you want to find the derivative of h, this is nothing but just simply find the derivative of the outer function, evaluate that derivative at g of x. So you need to find the derivative of the outer function, then evaluate at g of x, then multiply times f prime at g prime at x. This is what we call it chain rule. So a special case of chain rule is whenever h of x is equal to, let's say, a function f of x to the power of n. So in this case, it is a composition of two functions. So the inner function here is just like our placeholder of g is nothing but f of x. So in the outer, you see something to the power of n. So this is a composition of two functions. So which means x to the power of n and f of x. So if you find the composition of these two, it will give you f of x to the power of n. So chain rule says what now? The derivative of that guy becomes what? The derivative of the outer. The outer means now x to the n. From power rule, what is the derivative of x to the n? It is n x to the n minus 1. And then you have to evaluate with respect to what? The inner function. The inner function is now what? F of x. So which means it becomes now what? N times the inner function is f of x. I'm evaluating x at f of x to the power of n minus 1 times, it says what? The derivative of the inner. The derivative of the inner means what? The derivative of f. Derivative of f is notation f prime. So this is what we call it, the general power rule. The general power rule. General power rule. So if you have a composition like this, you'll be using this. But if you are having a function of this form, a function to the power of n, where n is rational number, okay? N is rational number, then you have to use this one. Let's see an example now. Example, let's say I have f of x. Don't think I should use f because you guys will be confused if I used. Let's say h of x equal to 3x minus 4 to the power of 9, let's say. So this is now what? A composition of two functions. What are they? The inner function is 3x minus 4. The outer function is what? X to the power of 9. So the derivative becomes what now? It becomes 9 times 3x minus 4 to the power of 9 minus 1 is 8 times the derivative of this, the inside, which is 3. So this is a special case of chain rule, which we call it general power rule. Let's see another example. What if I have h of x equal to e to the power of any function g of x? So again, this is a composition. So what are the compositions, or the components of this composition? The components are the outer function, which we call it f of x in the previous definition, is e to the x, and the inner function is nothing but whatever you have here, g of x. So every time you have e to the power of anything, the derivative becomes what? Okay, the derivative of the outer. What is the derivative of e to the x? It's itself, right? E to the x is itself. Now, I am evaluating the outer with respect to the inner. What is the inner? G of x. So f prime evaluated at g of x becomes e to the power of g of x. So this becomes e to the power of g of x times the derivative of the outer. The derivative of the outer, which is what? G prime matrix. So every time you see h of x equal to e to the power of g of x, then the derivative becomes what? E to the power of g of x, which is itself, times the derivative of whatever you have in the exponent. The special case of this guy will be, let's say I have h of t. You know, it doesn't matter. You can call it f, g, h. Why I'm using h? So that you guys can follow, because my h is the composition of an outer function, which I call it f, and an inner function, which I call it g. Other than that, it can be anything. For example, here, the independent variable is x. I can use a independent variable to be t. It doesn't matter. So, for example, special case is if I have e to the power of -5 over t to the power of 9, let's say. Now, which means what? My g is now this guy. So what will be the derivative? The derivative will be e to the power of itself, right? I mean, itself, which means e to the power of -5 over t, times the derivative of this guy, the exponent. Now, what is the derivative of -5 over t to the power of 9? I can use the law of exponent. This is -5 t to the power of -9. So the derivative becomes what? -5 times -9 t to the power of -9 minus 1. I'm using the power rule. So this will, because -5 times -9 is 45, t to the power of -10. So my answer will be 45 t to the power of -10. Now, you may say, I don't want to use a negative exponent here, just like this guy. You see, we have in the denominator. So that can be written as what? 45 is a number. I'll just keep it in the as a coefficient, -5 to the power of, over 2 to the power of 9. Everything divided by what? T to the power of 10. That will be the derivative of e to the power of a function. All right. So let's see another example. So the next example will be, let's say I have a product of two functions, which we can use product rule and chain rule. So I'll say h of x is x squared times radical of 9 minus x squared. So this is nothing but the product of two functions. I have a function called x squared. I have a function called square root of 9 minus x squared. So I have to use product rule. So to use product rule, I have to also use derivative of this guy, which is nothing but a general power rule, the second piece. So this guy can be written as what? X squared times 9 minus x squared to the power of 1/2. I hope you remember product rule. Product rule says what? F of x times g of x. Derivative means what? F prime at x times g of x plus f of x times g prime at x. It doesn't matter which one comes first. You know, if it is coming here first, it doesn't matter, because multiplication is commutative, right? You can commute. Order is not important. So let's go here. What is the derivative of x squared? 2x, right? Times the second. The second is 9 minus x squared to the power of 1/2 plus the first f, which is x squared, times the derivative of the second. What is the derivative of the second? 1/2 9 minus x squared to the power of half minus 1, right? Times the derivative of the inside. What is the derivative of the inside? Negative 2. So if you want to simplify this, this is 2x 9 minus x squared to the power of half plus, I have minus 2x here. You see here, I have a 2 here. So the 2 cancels out. I have x squared and x, it will be, by the way, this becomes minus because of the minus. X squared times x is x cubed. And I have half minus 1. So half minus 1 is negative half. And if you remember, I told you in the previous example, negative exponent can be written as denominator. So this is 9 minus x squared to the power of half. Again, if you want to write this guy as a common denominator, this expression as a common denominator, so which means I have to multiply this guy by this. So that would give me what? 2x times 9 minus x squared to the power of half times 9 minus x squared to the power of half minus x cubed, everything divided by 9 minus x squared to the power of half. So 9 minus x squared to the power of half times 9 minus x squared to the power of half, it becomes 9 minus x squared, because half plus half is 1, the same base, and then you add the exponent, half plus half is 1, minus x cubed, and I'm going to write this, what we call it, rational exponent notation using radical notation. So half means radical, 9 minus x squared. So this guy, if you distribute this, now it becomes 18x minus 2x cubed minus x cubed divided by radical 9 minus x squared. So the last answer should be what? 18x minus 3x cubed divided by square root of 9 minus x squared. Thank you for watching. I'll see you in the next video.